Hey guys, it's noon on Thursday. I'm going to be going through as many of the homework problems as I can, starting with the college algebra, and then getting to the calculus if I have time. If at any point in time, remember, if you ever want to join, I always post the Zoom call into the announcements section of our classrooms, and you may ask any specific questions you want over those problems. I'd be happy to do that anytime, okay? And if the times don't work for you, just shoot me a message, and I will try to find other times that I can help you or make videos specifically for you. Anything I can do to help out. So let's go ahead and get started. I'm going to be starting with the first one from our college algebra class. Ooh, that's really zoomed in. Oh my gosh. Let's fix that. Ow. That's a little better. All right. Ooh. Better? Worse? All the above. All right. Hello, Miranda. How are you this fine and beautiful day? Okay, I'm going to start with college algebra. Unless Miranda's got any specific questions she wants me to know about. So I'll be starting with day 8. Let's see, we had 35, 36, 37, 8, 39, 40, 41, 42, 43, 44, 45, 46, 47, and 48. Just right there at the bottom. Boom. Okay, 35. Answer should be 20x squared. 36. Answer should be 2y. You'll notice that for these, I am ignoring the secondary solution because remember, we're concerned only with the primary solution. And so 37, we'd have 7 square root of p. 38, we would have, so first thing I would do is rewrite this as the square root of 144 p squared q to the 6th. Remember, half powers are just roots. And from there, this would become 12p q to the 3rd. 39, the square root of 289, that should be 17. This would become m to the 5 halves times 17, or 17m to 5 halves. You could also rewrite the 5 halves power as 17m squared times the square root of m. Both those are considered acceptable solutions. 40, we would have 9m square root of 3 plus 3 square root of 3. This is considered an acceptable answer. However, you could take a square root of 3 out of everything and get square root of 3, 9m plus 3, and that's just fine. Either one of those is good because they are both simplified to the lowest possible root. 41, the b squared can move outside. This will become 3b square root of a. That's a b, not a 6. 3b square root of a minus b squared of a. I can factor square root of a out. Square root of a times 3b minus b. 3b minus b would be 2b, so this becomes 2b square root of a, not to be confused with 2b or not 2b. That is the question. 42, on top and on bottom. Let's see, I think the easiest one is to simplify the bottom first. 4 square root of 2n over, now 16, when square root is 4. N to the 4th would become n squared. From there, the 4's on top and bottom can cancel, leaving us with square root of 2n over n squared. I can cancel nothing else because the 2 cannot be radicaled, the n cannot be radicaled, and the n squared cannot cancel with anything because it's not in a radical. So that's acceptable. 43. I'm going to break it into 2 parts, the top and the bottom, but I'm going to simplify first. So we have 225x to the third over 49x. I see I have x to the third on top and an x on bottom. I could cancel those, leaving us with the square root of 225x squared over the square root of 49. So take an x out of both the top and the bottom and cancel them. Square root of 225 is 15. Square root of x squared is x. Square root of 49 is 7. 44, we end up with 3 square root of 44z plus the square root of 99z. I can take a 4 out of the 44z, and that would become a 6 square root of 11z. Plus, I can take a 9 out of 99z, and square root of 9 is 3, so 3 square root of 11z. I could then combine those together. Square root of 11z times 6 plus 3. And 6 plus 3 is, of course, 9 square root of 11z. Okay, 45. We have the square root of 50y to the 8th. Square root of 50 is 25 times 2, so that would be 5. Square root of y to the 8th would be just y to the 4th. The 2 did not have a friend to cop out with, so it would just be square root of 2. 46. Square root of 490 bc squared. Square root of 490 separates into 49 and 10s. That would become 7 with a 10 left behind. 10 breaks down to 2 and 5, neither of which are paired. B has no pairs, so it's going to stay inside. C squared becomes C, so it should be 7c square root of 10b. And again, I know it's done because what's inside, this is b, not a 6. I wish mathematicians would stop using b. I can't draw b and make it not look like a 6. So 7c square root of 10b. It's the lowest possible radical because I cannot reduce 10 and I cannot reduce b. 47. I would cancel first, like normal. So this would become the square root of 16 over 7d. Square root of 16 is 4. Square root of 7d is just 7d. Okay, I have to rationalize now, so I'm going to multiply by square root of 7d over the square root of 7d, which becomes 4 square root of 7d over just 7d by itself. 48. I would have q to the 3/2 power. Square root of 63 becomes 9 and 7. Square root of 9 is 3, leaving behind us 7 and a p. So we could write this as 3q to the 3/2 power square root of 7p. That would be one acceptable answer. Oops. Alternatively, instead of using that answer, I could move this into power form and get 3q square root of 7qp. These two are the exact same solution. It's just slightly different forms. In mathematics, you typically want to have all your answers in that same form to make the math easier to read. Like, it's weird to have rational powers with radicals. It's just weird in math. And so this is the preferred answer, even though this is technically also correct. Okay, let's look at the second homework assignment. 9 minutes, look at that. That's the last one before our quiz. So this would be algebra day 9. Boom. All right. We had 49, 53, and then 59 through 68. Okay, easy. Okay, on top, we get the square root of 8 over 1 minus square root of 3x. Is our original function. We're going to multiply by the conjugate, which would be 1 plus square root of 3x. So notice how the only sign we change is the one on the radical in the denominator. So 1 minus square root of 3 becomes 1 plus square root of 3, and we do it to both the top and the bottom. Notice the square root of 8 doesn't do anything because it's not in the denominator. The denominator is the only one we care about. This becomes, on top, we'd have the square root of 8 times 1 plus the square root of 3x. I'm going to multiply that here in a little bit, but I'm going to ignore that for right now. On bottom, we'd have FOIL. 1 times 1 is, of course, 1. 1 times the positive square root of 3 would be positive square root of 3x. Negative square root of 3x times 1 would be negative square root of 3x. And negative square root of 3 times the negative square root of 3 would become negative 3x. You notice if you did this properly, the middle two terms should always cancel. That's how you know you did it correctly, is that's the conjugate. On bottom, we end up with 1 minus 3x. On top, I will simplify a little bit. The square root of 8 is 2 square root of 2, and then I can multiply it through. 2 square root of 2 times 1 is just 2 square root of 2. 2 square root of 2 times the square root of 3x, the radicals would merge, becoming 2 square root of 6x. And there's our solution. I know it's my solution because there is no radicals in the denominator, and every radical that is left in the problem is reduced. So, oh, dang it. There we go. Again, going through our steps. Step 1, we have our function listed out, square root of 8 over 1 minus the square root of 3x. I multiply by the conjugate. The conjugate, remember, is the flipped sign of the denominator's radical. So 1 minus square root of 3x becomes 1 plus the square root of 3x. And then here is just doing my steps. So taking square root of 8 times 1 plus 3x, square root of 8 times 1 plus 3x. And then on bottom, we just FOIL and then reduce. And that becomes our solution. 53. I got the square root of 12, x on top. And on bottom, 2 plus 2 square root of 3. Just like before, I'm going to choose to use my conjugate, which would be 2 minus 2 square root of 3. Notice again how we did it. We flipped the sign on the radical portion of the denominator. So the 2 is still a 2. The plus is connected to this radical, so it becomes a minus. And again, nothing is done on the top piece. It is only the bottom that shifts, and it is done to both the top and the bottom. Now we have to multiply to the square root of 12x times 2 minus 2 square root of 3 as a top component. On bottom, we FOIL. 2 times 2 would be 4. 2 times negative 2 radical 3 would be negative 4 radical 3. Positive 2 radical 3 times 2 would be positive 4 radical 3. And then 2 radical 3 times negative 2 radical 3 would be negative 4 times 3, which would be 12. So 2 times 2 would give us 4. Square root of 3 times square root of 3 would give us just 3. 3 times 4 is 12. On bottom, again, the smaller terms end up canceling in the middle, which is good because it means the radical goes away. We end up with 4 minus 12 on bottom, which is negative 8. On top, we distribute and simplify what we can. The square root of 12x would become 2 square root of 3x. And so this actually simplifies a lot of stuff here. So we take 2 square root of 3x times 2. This becomes 4 square root of 3x. Negative times positive would make this negative. 2 times 2 would be 4. Square root of 3x times square root of 3. 2 times 2 would be 4. Square root of 3 times square root of 3. That would become a 3. So that becomes a 12 square root of x, because the x didn't have anything to tango with. So 4 square root of 3x minus 12 square root of x over negative 8. You could choose to get rid of the negative. You could choose to simplify some more by canceling a 4 on top and bottom. There's a lot more we could do here, but that's kind of like your minimum branch of where you have to finish. The best place to finish would be 3x minus 3 square root of x over negative 2. Taking a 4 out of the top and bottom. And we got 59. So now we got the square root of 144 over 324d squared. I don't think 324 is a nice one. Because actually it is nice. It's 18, I think. Yep. So square root of 144 is 12. Square root of 324 is 18. Square root of d squared is d. I threw it in a nice one for you. Look at that. What a nice guy I am. Okay, 60. Put it right there. We got cube roots now, so that means we need powers with threes. So 24x to the sixth. 24 would break down into 2 times 2 times 2 times 3. So we'd have 2x cubed come out with a 3 behind. It takes practice to do it that quickly. All you have to do is make sure to note each time you do so, which would be x squared, what would pop out. So the 24, in this case, breaks down into 8 times 3. The 3 would stay inside. 8, the cube root of 8 is 2, so the 2 would come out. The x squared would come out. We still have a cube root behind because we started with a cube root, and the 3 is left inside that cube root. Plus 81x to the sixth. 81 can be broken down into, of course, 9 times 9. And if we were doing a square root, we'd be done. But we're doing a cube root, so that's not good, which breaks down into 3 times 3 times 3 times 3, which means we have these 3 3s would all come out. So this would become a 3 on the outside and x squared with 1 3 left on the inside. Make sure the root should stay constant the whole time. It's a cube root here, it's a cube root there. We have 2x squared cube root of 3 plus 3x squared cube root of 3 for a total of 5x squared cube root of 3. I used factoring to get to that solution. 61. We got a fourth root now. Ooh, getting fun. Fourth root of 162x to the sixth over 16x to the fourth. For this one, I'm actually going to show my work this time, just to showcase kind of how we do it with these fourth roots. So on top, we'd have a fourth root on top. We'd have a fourth root on bottom. Okay, on bottom, 16 becomes 2 times 2 times 2 times 2. X to the fourth would just be x to the fourth. 162 becomes 2 times 81. We already did 81 once right here, which is 3 times 3 times 3 times 3. So 162 becomes 2 times 3 times 3 times 3 times 3. 16 becomes 2 times 2 times 2 times 2. And then x to the sixth would become x to the fourth times x squared. All right, look at that. Okay, remember, it's a fourth root, so we need 4 powers to go out. So a 3 is going to come out because there's 4 of them. And x to the fourth is going to come out from the top, meaning on top I end up with a 3 and an x. What's left behind is a fourth root with a 2 and an x squared still inside of it. On bottom, I have 4 2's, so a 2 can come out. And I have an x to the fourth come out as well, coming out as an x. Always double check, make sure this is as small a solution as you can get. You'll notice that there is an x on top and an x on bottom. Both are outside the radical, so we can cancel those, leaving us with 3 fourth root of 2x over 2. Similarly, we could have canceled that from the beginning, right? X to the sixth over x to the fourth, we could have used our power rule to turn this into an x squared on top, which makes more sense why we end up with x squared on top here. Make sure I make that clear, that is 2x squared. Okay, 62. On 62, we got the cube root of 64y. 64 breaks down into 4 times 4 times 4. times y. We have 3 4s, so a 4 can come out, leaving a cube root with a y still inside of it. 63. We have the cube root of 128 z cubed minus the cube root of negative 16. Ooh. Z to the third. Now, this one's special and kind of fun because of the negative. Now, in square roots, negatives pose a problem, but in cube roots, they're actually not that big a deal. And here's why that's so neat. Because how you write negative 16 is really special. Because one way of writing this, so I'll do the first part. We have the cube root of 128. 128 is 2 times 64. We already know 64 is 4 times 4 times 4 from the previous problem. And then z cubed is z cubed. Minus, here's the cool part, how we choose to write the negative 16, because there are actually lots of things that can make negative 16. And one of those would be negative 2 times negative 2 times negative 2 times 2. Z cubed. Negative 2 times negative 2 would become positive 4, times negative 2 would become negative 8, times 2 would become negative 16. This is just a different way of doing it. The other way to think about it is, if you have an odd power, the negative will just pop out. Because watch what happens. Over here, the cube root, the 2 has nobody to tangle with. We got 3 4s, so the 4 can come out. We have 3 z's, so the z can come out, leaving behind the cube root of 2. Minus, we have 3 negative 2's. So a negative 2 can come out, meaning I'm going to end up with a double negative here. We have 3 z's, so a z can come out, leaving behind a cube root with a 2 inside of it. The double negative is going to make that positive. We have 4z cube root of 2 plus 2z cube root of 2 for a total of 6z cube root of 2. Good times. All right, got 3 left. Let's do them. Got 64, which is, fifth root. Ooh, fun. Fifth root of a big number, 1024, c to the 10th. All right, if you do not know what the breakdown of 1024 is, you can use your factor tree. 1024 is 2 and 512. 512 is 2 and 256. 256 is 2 and 128. 128 is 2 and 64. And we've already done 64 once, so I think I'm going to be creative with this. So 64, you'll remember, is 4 times 4 times 4. So there's a 64. I have 2 2's here, which together makes another 4, and 2 2's here, which together makes another 4. Ooh, that's handy, because this becomes the 5th root of 4 to the 5th power, c to the 10th power. The 5 can cancel, leaving a 4 behind. The 5 can cancel, leaving a 2 behind. Ooh, look at that. So the 5th root of 1024 must be 4. There we go. We got 2 left. These ones were fun to put at the end. About to be a nice little change of pace. We got the square root of 8 minus the square root of 16 over 4 minus the square root of 2 minus 2 to the 1/2 power. Okay, let's do it. Square root of 8 is 2 square root of 2. Square root of 16 is 4 over, on bottom we have 4 minus the square root of 2 minus 1/2 power becomes the square root of 2. Notice how I take time to convert them all into the same form. So they're all in radical form here. And because they're all in radical form, I reduce them to the lowest radical form. All right, next. And then I can do, let's see, I want to use the conjugate on this first term. So the minus square root of 2 is going to stay on minus square root of 2. I'm not going to do anything to it. But that first piece, 2 square root of 2 minus 4 over 4 minus square root of 2, I'm going to use the conjugate to fix that piece. So to do 4 plus the square root of 2, 4 plus the square root of 2. Again, you have to use the conjugate of the denominator, not of the numerator. So I use 4 plus the square root of 2 as my two pieces. Again, this piece is separate. I'm going to deal with it later. So let's do the first piece again. Square root of 2, I'm not doing anything to. Let's take care of the top. 2 square root of 2 times 4 would become 8 square root of 2. 2 square root of 2 times a positive square root of 2 would become 4. Negative 4 times 4 would become negative 16. Negative 4 times the square root of 2 would become negative 4 square root of 2. There's the top. On bottom, 4 times 4 would become 16. 4 times the positive square root of 2 would become positive 4 square root of 2. Negative square root of 2 times 4 would become negative 4 square root of 2. And negative square root of 2 times positive square root of 2 would become negative 2. All right. When I simplify, I have to simplify the bottom as one thing and the top as a separate thing. I can't cancel because there's pluses and minuses involved. I can only cancel if there's multiplication or division. So for here, on top, I have 8 square roots of 2 minus 4 square roots of 2, leaving behind 4 square roots of 2. Over here, I have 4 and negative 16, leaving behind a negative 12. And here, I'd have these two middle terms are going to cancel, but they should. And I end up with 16 minus 2, which would be 14. Now, this right here is actually an acceptable answer because it follows all of my rules. All of them are either in power form or radical form. In this case, they're all in radical form. There's no radical in the denominator, and every radical that exists is reduced. So this is actually an acceptable answer. Now, that doesn't mean it's the only answer. You could merge these two fractions together by taking the second one over here and writing it as over 14. Remember, that's always an option. You just have to do it on both top and bottom. The reason why I want to do it this way is so that they match denominators, like so, allowing me to actually put these two together. 4 square root of 2 minus 14 square root of 2 would become negative 10 square root of 2 minus 12 over 14. And if you divide the top and bottom by 2, we end up with negative 5 square root of 2 minus 6 over 7. I guess we could have reduced this one step more by canceling a 2 out, but I mean, that's pretty small. Both these are considered acceptable. They're just different ways of writing the solution. 68. Remember your rules for simplifying and follow them to the letter. You stop whenever you've met your rules. Remember those rules are there needs to be no radical in the denominator. Every radical that is in the problem needs to be reduced, and every fraction needs to be reduced if possible. So 68. And make sure they're all in the same form. So 4 3 over 2 minus 16 3 over 2 divided by 8 to the 1/3. Oof. Okay. Okay, this is looking interesting. Okay. Let's start by putting them all in the same form. I'm going to put them all in radical form. So on top, this would become, I'm going to simplify a little bit, 4 square root of 4. Wait a minute, 4 square root of 4. I'll fix that in a second. Minus, this will become 16 square root of 16. There's a little pattern here that 3/2 powers always do this. Over 8 to the 1/3, so that would become a cube root of 8. It turns out every one of these simplifies. 4 square root of 4 is actually 8. 16 square root of 16 is actually 64. And the cube root of 8 is actually 2. Now I do my subtraction next. 8 minus 64 would become negative 56 over 2. And 56 divided by 2 would be negative 28. That's our solution. Oh, that was nice. Look at that. You could also just type this in, like the 4 to the 3 halves power is 8. 16 to the 3 halves power is 64. Notice how the number increased in size because the coefficient or the radical's power was larger than 1. That always happens. Okay, so there's the second homework. Let's look at our third. Yeah. That's the one from today. I thought the one from today went by pretty quick because there's a lot of stuff in here you've done before. So if it looks like it's really long and complicated, it's not. Called Algebra Day 11. So we have 5, 6, 7, 8, 9, 10. These are all pretty similar. Okay, on number 5, it wants to identify the degree. Degree is the highest power available when combined. Highest power on 5 is a degree of 2. 6, we got a power of 3, a power of 2, a power of 1, and a power of 0. So tell me it's degree 3. And we're highest power wins. On 7, we had a power of 8 and a power of 4. That makes this degree 8. On 8, we have, okay, on 8, we have, make sure to mark this one out so everybody can see it, 200p minus 30p squared m plus 40m cubed. So these two have a combined degree of 3. This one has a degree of 3. This one has a degree of 1. And so the overall degree is a 3. Remember, it's just the highest one. If there's a tie, then it's that number, as long as it's the highest number. For 9, be a degree of 2. For 10, it would be degree 5. Okay, next ones are all addition and subtraction stuff. That should be pretty straightforward. So for 11, we add, subtract those two. We end up with 4x squared plus 3x plus 19. Remember, when you add those together, a double negative would make it positive. 12. Let's see, z cubed, we only have 4z cubed. Z squared, we got 8z squared plus negative 2z squared for a total of 6z squared. Negative z plus a positive z would make 0, so it's going to disappear, plus a positive 6, so plus 6. 13. The big one here is to remember that if you have a positive version, negative version, make sure to distribute the negative sign or positive sign if you need to. 13. Got 6w squared is the only w squared, so 6w squared. We have 24w minus 3w, so that would make it 21w, minus a negative 6w, so it becomes addition. So 21 plus 6 would make that a positive 27w. All right, we have 24 minus a positive 3. 24 minus 3 would be 21. 14. A cubed. Okay, we got 7a cubed and plus a negative 3a cubed for a total of 4a cubes. We got 6a squared plus a negative 4a squared for a total of positive 2a squared. We have negative 4a plus 6a, which become positive 2a. And negative 13 plus a positive 17, which become positive 4. Okay, looking good. 15. Let's b to the fourth is the highest one, so we got 11 b to the fourth. B cubed, we got negative 6b cubed minus 3b cubed for a total of negative 9 b cubes. Positive 18b squared minus 6b squared makes a total of positive 12b squared. Negative 4b minus 3b would make a total of negative 7b. Plus 8 is plus 8. And then 16. Let's see. Oh, we got some p to the fourth, so I'll do those first. 16 p to the fourth. P squared, so we got 49 p squared minus 32 p squared for a total of 17 p squared. Minus 25 plus 16 makes a total of negative 9. Note how I'm doing the largest degree first. That way I always put it first in my solution, so it's in proper order. And then I continue to work down. And the big questions are always going to be what's the signs. So keep track and distribute when you need to. 17, 18, 19, and 20 are all the multiplication problems. Let's go through those pretty quick. It's just can't you FOIL. 4x times 6x is 24x squared. 4x times negative 4 would become negative 16x. 2 times 6x would become positive 12x. 2 times negative 4 would become negative 8. Combine like terms. This would become 24x squared minus 4x minus 8. 18. Okay, just multiplying them. 14c squared times 2 squared would become 28. 14 times 2 is 28. C squared times c squared would become c to the fourth. Okay, 14c squared times negative 3c. Negative 3 times 14 would become negative 42. C squared times c would become c to the third. 4c times 2c would become 8c cubed. Positive 4c times negative 3c would become negative 12c squared. Combine my terms. 28c to the fourth. Negative 42 and positive 8 would make this negative, oh, can't do that in my head for some reason. Negative 34c cubed minus 12c squared. Okay. Then we got 19 and 20. That'll be it for college algebra. All right, 19. 6b squared minus 6. Ugh, why do they got to use b's? All right. 4b squared minus 4. You the devil. All right. 6b squared times 4b squared. 6 times 4 is 24. B squared times b squared is b to the fourth. 6b squared times negative 4 would become negative 24b squared. Negative 6 times positive 4b squared would become negative 24b squared. Look at that. Negative 6 times negative 4 would become positive 24. So combine like terms, this would become 24b to the fourth minus 48b squared plus 24. And then 20. 3d minus 5 times 2d plus 9. This would become 3d times 2d would become 6d squared. 3d times 9 would be 27d. Negative 5 times 2d would become negative 10d. Negative 5 times 9 would become negative 45. Combine like terms. This becomes 6d squared plus 17d minus 45. Woo, college algebra done. Yeah. All right, Miranda. It's calc time. Are there any questions that you had over the calc assignments?
Yes, I do have some questions.
Sweet. I love questions.
Okay, so on calculus day 8, the transformations and composites.
Huh?
My question is 65, just all of it. I wasn't sure exactly what I was supposed to do.
Okay.
I got very confused very fast.
Yeah. I'm gonna put that up here, and so we can see it kind of in front of us. And I'll talk my way through it a little bit, and then I'll show my work on my page afterwards. Okay.
Okay.
So screen share.
Because I'm used to working with equations, and that just confused the crap out of me.
And the weird thing is, like, most people are, and you get to calc, and suddenly everybody's like, "Hey, do it this way instead," and you're like,
Yeah, I like working with equations.
Okay. Can you see that? Can you see 65?
Yeah.
Okay. So I'm going to do 65 at the same time on my paper. Let's talk about what A says. What A says is we want to do f of g of 3.
Sure.
So what this means is we want to take the function f and plug g of 3 into it, which means we want to plug 3 into g, then plug your answer into f. So let's look at that picture, okay? So the top line is the f line. The bottom line is the g line. So let's break this down into some pieces. Okay, so first, the number 3 indicates 3 on the x-axis, right? Because that's what it always means.
Yeah.
So if I want to find out what g of 3 is, I go to 3 on the x-axis and find the equation for g and read the answer. What is g of 3 in this case? Take a look at that picture, find 3 on the x-axis, and then find where g is on the y-axis.
So 3 on the x-axis, right there. Y-axis. Well, this is common. G on the is right there for 3. So on the y-axis, it's like -3, kind of.
It should be -1. See it right here?
Yeah.
So there's
Oh,
3
that's what.
right there.
That's what you meant. Okay. Yeah, I
Is
got
that
you.
better?
Yeah.
Okay. All right. So now what this means is if we look over at my page real quick, you can kind of see that now the number we're looking at is -1 because that's what g of 3 is. So now what we're going to do is we're going to look at the f function at -1. So we use the answer from the first part of the question and plug it into the second part of the question. Okay? So let me ask you now. We've got g of 3. You just said it's -1. What's f of -1?
-4.
Yeah. So I'll switch back to my view so you can kind of see how the math looks. Right there. So what we did was, this is the original equation, right? Which we can rewrite as f of g of 3.
Okay.
We then do this inner piece first. We do g of 3. What was g of 3? It was -1.
-1.
And then we take that -1 and try to solve it with f now.
Which is 4.
And so what is f of g of 3?
Okay. That's it? That's not too bad then.
It's not. It's just weird. You've never done anything like this before, probably.
Yeah.
So let's look at B now.
Used to it.
So it says g of, oh, it actually has it written correctly. G f of 2. So I like to do this. This is my thing. You don't have to do it. But I like to write out what this means in words. This means we're going to take 2 and put it into f, then put it into g. So we're going to take 2, put it into the f function first, then plug that answer in for g. Let's go back to that picture, okay? So go back, boom. All right, so now we're here. So what is, let's answer that first piece, what is f of 2? And you can assume these are nice numbers. Like, don't ever assume it's like 1.8 or something, right? Assume they're meant to be nicely read.
Okay, f of 2, and that's f is the x-axis?
F is the top line.
Yeah, top line.
So you go to 2 on the x-axis.
Yeah, and wouldn't that be 1?
It would be 1.
Okay.
So really, it says g of f of 2. What it really means is what's g of 1. because f of 2 is 1. And so you basically do a substitution. Okay, well now we ask the second part, which is, okay, well, we know f of 2 is 1. So what's g of 1?
G of 1 is -2.
So let's ask the bigger question. What is g of f of 2?
Is -2.
Notice how this chain works. We start with the innermost piece, 2. That means 2 on the x-axis. What do we do to that 2? We look at the f function. Where's 2 in the f function? And then we use that answer, which was 1, and plug that into the g function. And that becomes our solution. Okay, what about C? You wanna try it first?
Yeah.
Okay. Let's see if we get the same answer, okay? And do note, because of the instructions, it says if the result is undefined, explain why. So there's a possibility that sometimes it doesn't work. I'm not saying it's going to happen here, but it might happen on one of these.
Well, this one doesn't have G negative.
So if this doesn't exist, what would we say our answer is?
Undefined, right?
Correct. Why is it undefined?
Because G doesn't go down to -5.
Yep. Like you just said, everything you need to say, you just got to write it down. So you said this doesn't exist. So I wrote doesn't exist, undefined. But again, note how the chain works. You start on the x-axis at 5. We read the f function's value of 5. And we take that answer and plug it into G. You're always working out towards. It's like you start in your house, you start your day in your room, then you travel into your house, then hopefully you travel outside someday. Okay? D. All right. What'd you get for D?
I messed up. I did 3 instead of -3. Hold on.
It happens more than you think. And see, questions like these force you to understand the material better because you can't rely upon an equation as much. You have to be able to look at it and go, okay,
Yeah.
what is f of 2? Well, that's just a point on a grid. And if I plug that into another function, well, that just means plug your answer into the other function. And so it really stretches your brain a little bit. I wish we did this more in other classes, but I'm sure my freshmen would revolt. So I'm going to go ahead and do E and F real quick. I'm taking up a lot of space. I would normally only write my answers because once you get into the hang of these go by really quick. So E.
That one's undefined too because f doesn't have.
Very good. That's what I got as well.
Cool.
All right.
Well, then I'm good on that one. I also have questions on calculus theory and limits, and I haven't even started on today's work, so I don't know.
Today's work is basically the same, but they don't give you the table. I show you in the video how to make the table. Okay.
Okay. Gotcha.
So I'll open up theory and limits. Okay.
My main question was on the estimate the value of the median point then compared to the actual value thing. I'm not 100% sure on what it's asking for because it seems like it's saying find the median and then say what the median is. What? I don't.
That's because what happens when you actually try to plug it in. Okay, so let's look at number one. Okay.
Okay.
We'll do that one together.
I think I plugged everything in right.
Well, good, because I'm going to ask you to help me out because I don't want to plug all that in right now. All right, for number one, I'm going to make my table real quick. This table is pretty crucial in the first chapter of calculus. Learning how to make it quickly and efficiently is really helpful. And the thing is, in calculus, you'll get to choose points like these, which is really neat.
I remember if we ever did tables in just like at school, Miss B, my math teacher, she always does -2, -1, 0, 1, 2. Like those are her go-to like 5 numbers.
That's great. But in this case, if I'm trying to look around 4, because in this case we're doing a limit, so we're looking around a number.
Yeah, because
like -2, -1, 0, 1, and 2, they're not actually near 4 on the cosine scale, right? So, okay, so give me your, what is 3.9?
0.2041. I figured round to,
That's good. What about 3.99?
0.2004.
3.999?
0.2000.
Beautiful. 4.001?
0.2000.
4.01?
0.1996.
Okay. And 4.1?
0.1961.
Okay. So let me ask you this. If you look at both ends, you can see how they're getting closer and closer together in the x's, right? Because they're each getting closer to 4. So on top, what's happening is we're getting closer and closer to a value of 4 as we move from the outside inwards. What's happening on the bottom?
Well, it hits to like 0.2.
Right.
So it seems to get closer.
This is what we call the limit, because this is what the left-hand side and the right-hand side appear to be going towards when we plug them in. But let me ask you a question. Did you actually plug in 4? Did you take x minus 4 over x squared minus 3?
Well, wouldn't it just be 0 because 4 minus 4 would be 0, and then 0 divided by anything is 0?
But there's something special that happens because of what happens on the bottom. So plug in 4. You're right on top. You get 0. What happens on bottom?
16 minus 12 minus 4. Is that going to be 0 too?
Yep. And are you ever allowed to divide by 0?
No, so it's undefined.
Correct. So by the limit, we got a number. We got an answer, 0.2, right?
Yeah.
But when we actually plug it in, we don't get an answer. So this is the difference between a limit and the actual value. So a limit may get an answer, 0.2, but the actual value may not exist. And so this is really helpful if you are dealing with like incomplete data or data where you have what's called volatility, meaning there's places where things don't go according to plan. Like here, 4 is a problem because we expected to get 0.2 and we didn't. And in fact, if you were to graph this, like let me pull up Desmos real quick so I can kind of show you what this looks like.
So when it says use your calculations to estimate the value at the median point and the actual value of the median point, we think it should be 0.2, which is the limit, but it's actually undefined.
Correct. And it turns out, I'll give you a heads up for all 4 of these, they're all undefined.
I figured that's how it's going to end up being.
So let me tell you my equation.
What are, we're going to be like, yeah, it should be this, but it's actually undefined, and so that's what we have to compare.
And the irony is we care more about what we think it should be.
Than what it actually is.
In mathematics, we can use this to fill in some gaps in missing knowledge. Because like, let's say there is a gap, but we don't want there to be a gap. Like, let's just say we don't want there to be a gap. Well, we can do that. Because basically we can take this information and be like, hey, there's a problem here. Let's just use this number instead and pretend there isn't a problem, which seems awful coming from an algebra background. But in calculus, you start looking at more and more realistic situations, and it becomes very important to be able to look at it that way. Here, let me pull up Desmos here for you. So there's Desmos. And the thing about it is, if we go over to 4, the graph looks fine, but at 4, there's a problem. See, it's nice and undefined, right? Boop, there. This is called a hole. And if you're just looking at the graph, like you can't tell the hole's there. It's only when you actually evaluate the value versus evaluating the limit. And you can see if you actually drag your mouse closer to 4, you can see how we keep getting closer and closer and closer to 0.2, exactly like we found by calculations. But when we actually get to 4, it stops working. And so this is
like
the limit.
My limit is 0.2, but the actual limit is undefined.
So terminology here is going to be key. So the limit is 0.2. The value is undefined.
Oh, gotcha.
Okay? It's a small thing, but it really sticks out. Okay, so the limit is 0.2. The value is undefined.
Gotcha.
And so we use this a lot, like when we were designing aircraft wings. You'll find that turbulence spikes at certain values, and it spikes so that it causes a destructive behavior. And what you can do is you can use that fact to say, okay, well, let's work around those points and see if we can find a better way to approach them. And so instead of using that, point undefined value, we use the 0.2 value and are able to get a solution that way.
So this is kind of like an engineering kind of problem?
It can be. And that's the big thing about calculus, is that it becomes more and more and more about realistic situations, because calculus was created to solve realistic problems. So like this is a problem in a realistic situation. Like you can't get the answer, right? We plug in 4 and we don't get an answer. But we should have an answer of 0.2. And so from a realistic situation, we get an undefined answer, but from a practical standpoint, 0.2 should be the answer, because it's what we expect to get. Just because it doesn't exist there doesn't mean it's not what we expect to get. And that's a small detail that's really crucial in a lot of math and engineering applications.
Gotcha. All right.
And for today's material, the only difference between that is that you're asked to make your own table as opposed to me giving you one. And I walked through the steps of how to make a table, like how we chose like the 0.3, the 3.9, the 3.99, and 3.999. Like there's a very specific process to always generate this table. And once you have the table, it's just plug and chug. It's pretty straightforward.
All right. So it's like basically the same thing as yesterday, just we make our own table.
Yep. And I walked through the process of how to make it.
Cool. That's not bad then. I just didn't have time to start it yet because I still have other homework to do.
Oh yeah, I understand. And if you have to turn in something late, as always, and this applies for anybody, if you turn anything late, just let me know. I don't mind taking late work as long as I know it's coming.
I mean, you said it's all due tomorrow anyway, so I should be good.
Okay.
I just gotta write everything down.
Cute. Do you have anything else you wanted to ask me about? We got a minute left.
I don't think so, because all I have to do is start on limits. I mean, limits continued, and I think that's all I had questions on.
Well, if you have any more questions, just shoot me a message, okay? I'll be happy to answer them.
All right, okay.
All right. I'm going to go ahead and I got to get to the store. I don't have any food and I'm dying here. So, all right. I'll catch you later, okay?
Okay. Thank you. Bye.
Bye.